Okay, so today we'll be talking about file permissions. Permissions are essentially what a person is or is not allowed to do. For example, you could have the permission to write a file, or maybe you won't have the permission to write a file. So let's get started. So if I do this command, lsla, I will see all the files as well as their owner and the group that owns it. So over here, let's say this file, AAA. So over here, there is 10 characters. So the first character is probably going to be a dash or a D. If it's a dash, it's a file. And if it's a D, it's a directory. So over here, we have 9 dots over here. The first 3 dots right here are what the owner of this file can do. The second 3 are what the group owning it can do. And the third 3 is for everybody else. So over here, we have 3 dots over here. So the first one says R. Now this means that the owner of the file can read this file. The second one says W. This means the owner of the file can write the file. And the third one is a dash. This means that the owner of the file cannot execute the file. If the owner of the file wanted to execute the file, you would have to put the X there. Now onto the group. It is the same thing as the owner. They can read and write but cannot execute. This is the third one. Everybody else can read it but cannot execute it or write it. So here is the directory. So for directories, it's going to be a little bit different from files. So the first is the X. X just means they can just X instead of executing it as you would normally do with a file. It means a user is allowed to go into the file directory and navigate around. So in this, you can see here that it says RWX. So this means that the owner of this directory, who right here is called the better one. So the better one can officially go into the directory and navigate around. So about the W. So W, instead of just writing the file, it means that you can add or delete entries in the directory. So over here, it says RWX. So this basically means that the W there, it means that the better one, who is the owner of this directory, can mess around with the entries inside it. So that's the basic differences between the directories and the files for the permissions. So yeah. So now we have to discuss another thing. So to set permissions, you need to know things about binary and octal. So basically, binary is the number system with radix 2. Octal is a number system with radix 8. Basically, binary has 2 possible digits for each slot. You can either have a 1 there or a 0 there. Octal can have digits from 0 to 7. So in order to set these permissions, you're going to need to know something about that. And so now we are going to set some permissions for, say, AAA. So I think the command here was going to be chmod. So that will be the command to set it. And then you just put the file name and then whatever permissions you want to set. Wait a minute. Hold up. It could also have, wait a minute. Oh yeah. We switch it around. You put the permissions first. Now then, let's look at it again. So here, AAA, you can see it's green. That doesn't really affect anything, I think. So over here, it looks like these permissions have changed. It used to be RW dash, RW dash, R dash, dash. But now it's changed to RWX, R dash, 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 X. So basically, we have changed it to the owner can do everything, read, write, and execute. The group can read it, and everybody else can execute it. So this is obviously a set of permissions you're probably not going to be using, but here's how it works. So you will have to put 3 numbers in, as said before, for each of these 3 sections. So the first one, you'll have RWX. Now, for RWX, if you want to put a letter there, in binary, you would put a 1. If you want to put a dash, you would put a 0. So if you want a permission to be allowed for a user, you would put 1 there, and if you don't want it to be allowed, you put 0. So in this section, let's say if we want people to be able to read and execute but not write, it would be 1 and 0 and then 1. So 1, 0, 1 in binary converts to 5. So then the person, you would then put the 5 for that section. So if you wanted everybody to be read and execute but not write, we would do cmod AAA 555. Yeah, wait a minute. Yeah, like this. So now if you look at the permissions, it will be read and execute, read and execute, and read and execute. So let's do some exercise. First, convert some numbers from binary into decimal, and yeah, just convert some binary numbers into decimal. I will put the binary numbers in the chat. Okay, I'll just put one binary number in the chat. Convert that to decimal, and then after that, make your own file and set the permissions such that the owner of the file can read and write and execute. The group that owns the file can read and write, and everybody else who is not the group or the owner can only read. So I'll give you I'll give you until 7:46 to do that. So 5 minutes. So 5 minutes to convert that number into decimal that I put in the chat and create your own file and set the permissions. So are all of you mostly finished? So I will take that as a yes, you are all mostly finished. So let's go on to the next part. So now you kind of know what these 10 dots over here stand for and what these over here stand for. So let's say now you want to change the owner of a file. So in order to change the owner of a file, you have to use the ch own file, followed by the new owner, let's say root, and then followed by the file name. So AAA. Okay, so changing ownership of AAA is not permitted. So let's just. So if you look at it now, the owner of AAA will now be root. So we have changed the owner of AAA. Now let's see how to change the group. So in order to change the group, you will use the chgrp command to change the group. I think it should be the same format. So if you look at it now, yeah, the group that owns AAA is now root. So I'll give you maybe a few seconds or maybe a minute to like change the owner and the group owner of a file. Okay, so I think you should be mostly done with that now. So now let's talk about another thing. So we've already talked about these file permissions. So let's see how to use these permissions to maybe, like, if you're attacking a system, escalate your privileges so that you have a admin or root privilege. So if you are attacking a system, you first gain access as a normal user, and then you try to get the admin or root privileges. So one way to do this are the SUID file. So SUID is basically something that allows you to run a file as the owner of the file. So by default, some like files are enabled for this, such as the password command file. But the command to find some of these files, I'll put them in the chat. It is find slash dash perm dash u equals s type f to greater than sign slash dev slash null. So basically, the find is just find the files. Slash means you start from the root directory to look for it. Perm is just look for the permissions. U equals S means that you want it to be owned by the root user. Type means typed by file. Yeah, so type F is file type. 2 is just like the 2 and the that and the dev null. You just throw away all the output into that. So the output will all be thrown away. So in order to exploit UID, let's look at a way to exploit this SUID. So here we have this. Wait a minute. Hold up. Okay then. So here we have the first method to exploit this SUID. So first, let's assume you have successfully infiltrated your machine you want to attack with normal privileges. So you want to escalate your privileges. So as said before, you can use this command that I've highlighted in blue in order to find the SUID. So over here in this image, you've seen some ways to connect. So this is the connection. And now you have listed all the things with SUID. So over here, you'll see /bin/gp. This is the copy. So now you know that you can run that with the permissions of the root user. So you can officially run it as a root. So now you can copy /etc/password into you can copy it somewhere. Here it's the HTML directory. So now you have generated a new encrypted password, pass123, using open. Yeah, I'll send you the link. Okay, I will put the link in the chat. Okay, so here you have pass123 using open SSL password. Now we have copied the password file into the web directory /var/www/html. So you open it through the web browser and then copy it into the /password file into a text file and then add your own user. So here we have this /password file, and here you see he has put in his own user hack, and then he's put in his own user hack. So if you now it says run Python HTTP to transfer your edited password file into the machine. So this is basically just going to put your edited password file into the machine you want to attack, and the /temp directory has the permission to create or delete any file. So you've downloaded your password file inside it, and now you can and since the copy command has the UID SUID as the root, so you're allowed to use it as the root user, as the owner is the root and as the SUID. So you can now copy your new password file from /temp/password into /etc/password. And it'll overwrite the original password file. So now you can see that you have successfully implemented your own user hack into the system using only this SUID for a command. The hack user is also a root user, so this is pretty dangerous. So it says second method. So similarly, if the SUID bit is enabled for the CP command, we can also transfer our backdoor to the target system. Here we have generated netcat backdoor for reverse connecting using this command, msf venom. So this command right here, I will put it, if you want me to put it in the chat, I'll put it in the chat. So copy the highlighted code above and put it into the text file by editing bin bash and ready to transfer to the target system. So he saved it as raj.sh. So we are all aware of the cron type utility. The cron type utility is just a thing that runs your tasks, that automatically does your tasks periodically. So he has now copied raj.sh into /etc/cron.hourly. So it will run raj.sh after 1 hour. So as you know, this raj.sh had a netcat. So after an hour, the netcat listener will be open and it gets connection with the root privileges. Hence, we show how a single copy command can lead to privilege escalation if the SUID bit is on. So to recap these, here we have the SUID for copy command. So one way for this copy command to exploit is that you use it to copy /etc/password, edit it, and then put it into /temp, because /temp can store all the files, any file, and then copy it back to /etc/password. It will overwrite it, and you inputted your new user with the root permissions in it. So now there will be a new user with root permissions in it, and you can log into that user. The second way to do this was by using the copy command to create a file with a netcat backdoor, and then copy it into one of the cron tabs. Once it's copied into the cron tab, it will automatically run after a certain amount of time, and then you have a backdoor. So, are there any questions about this?
So I have a question because I run the first command on my Unix on my Ubuntu. I didn't see the copy command shown up.
Well, I mean, I also ran it before. It didn't show up. I think that it's not supposed to show up because something like this could happen. So, so this is a demonstration of what you could do if you find this. If it does show up, that's pretty great for you.
Yeah, so basically, the copy format that because the set UID basically is to allow the program to run with root permission. So that's really very dangerous features. So you need to be really very careful. So the copy command by default does not have that set UID enabled. So if you want to enable it, you can try to, you can use the change permission command to assign the set UID permission, then it will show up that you can run the test. But the demo is just so, if we have this kind of program in our system, that probably is a sign that there's maybe a backdoor for bad guys to come in. So you, if for example, in the Cyber Patriot competition, you probably want to search all the programs with set UID and see if there are any like abnormal files or program with that your set UID configured. If if you find it, maybe you want to disable it. Yeah, so this the demo here, it just show this not a secure way. This is not a secure system, so that's why the bad guy can run this kind of escalation.
Thanks.
Yeah, what was said before, the given root permission to execute these commands is you need to be careful to do that. So by default, the copy command is turned off. If you suspect there's somebody rummaging around in your system you don't want in there, you probably don't want to turn it on. You can turn it on for experimenting like this. So now let's go into more methods. So another here, it says privilege escalation using find command. So it says you can escalate root permissions if suid is on for /user/bin/find. This is where you probably should be finding your find command. So it says, for example, suppose you, your system admin, want to give suid permission for find command. You can use which, the command which, to identify its location and current permission. After that, you can enable suid bit by changing permission. So over here, you're enabling the suid bit. Again, compromise the target system and then move for privilege escalation phases down above. Then by using the following command, you can enumerate all binaries having suid permission. This was the command we used before. And then it says, so here we came to know that suid bit is enabled to find command, which means we can execute any command within find command. To do so, we create an empty file called Raj and run the who am I command below. So touch Raj creates new file Raj, find Raj, execute who am I. If it is successful, attacker successfully enumerated suid bit for user bin find, will allow him to execute any malicious command to netcat bin bash or maybe fetch important system information for further escalation. So over here, it shows the terminal. You can see that bin find, user bin find has been allowed for the suid bit. And then they created file Raj, and then for Raj, they execute and then it said root. So they've essentially gone root. So here it says privileged escalation using Vim editor. So once again, it said similarly, we can escalate root privilege if suid bit is on for Vim editor. For example, suppose you, system admin, want to give suid permission for Vim editor. You can use the which command to find it, and then you can enable the suid bit by using basically the same thing as before. You will find vim.basic. User bin vim.basic. You can compromise the target system and then move for privilege escalation as done above. So here we know that suid bit is enabled for user bin vim.basic. So user ignite is not a root user who has the least permissions, and since vim is suid permissions, you can edit the sudo file and change permissions for user ignite. So you open sudo file by using vi sudo command and give all permission to user ignite as shown below. Ignite all equals all. Basically, ignite gets to do everything. As you can see here, this is the same permission as root. So then we can access root directory as shown in the below image. So this also works for the privilege escalation as well. So to summarize for these two, the first one is the compromise find command. This allows you to just use the find command as any command and help you get the root privileges. The second one is using Vim editor. This one allows you to use the sudo file, and then you can give yourself the same permissions as the root. So are there any questions for these two? Okay, then. I will assume there's no questions, so let's go on. So privilege escalation using saved script. So these are maximum chances to get any kind of script for the system or program call. It can be any script using PHP, Python, or C language script. Suppose you, a system language, want to give suid permission to a C language script, which will provide bash shell on the execution. So here we refer a C program, which will call for a bash shell and save it as asroot.c. Then create a root shell directory inside /bin and copy the asroot.c into a root shell directory and run gcc compiler for compilation. Now then compromise target system and use find command to identify binaries that have been suid. So here you came to know that US suid is enabled for so many binary files we're interested in /bin/root shell/shell. So we moved to /bin/root shell and run the shell script and result and got root access as shown below. So we go into this, we run the shell. Hence we saw how we can escalate root privilege if suid bit is enabled for any script, although it's not possible to get such a script that bash shell. If you find any script with suid permission using above technique, you can modify the contents of that script to get bash shell. basically script with US SUID can be used to get the bash shell. So here we have privilege escalation using nano editor. Similarly, we can escalate root privileges if SUID is on for nano editor. For example, suppose you system admin wanted to give you SUID permissions for nano editor. They can execute these commands and then compromise it, use this command, which we've already used a lot before. So here we came to know that SUID bit is enabled for bin nano. So let's open the /etc password file, edit own user as done by open SSL password. So here we've generated a new password, 123. So we have open password file using nano editor and add your own user. Here can you observe we created demo user with encrypted password. He's added the root user. And then su demo, and then you are now the root. So this is pretty similar to the way first one we saw all the way up there. So here we have another one. So if it's enabled for nano, you can steal the password from inside the /etc/shadow file. So right after compromising target machine, we can open the shadow file and copy the encrypted password for user Raj. So over here we have user Raj and this. So paste the copy code into a text file and save the hash, and use John the Ripper to decode it. So John the Ripper is generally described as a hacking tool in Cyber Patriot. So it is given Raj123 as a password. So try to log into the target system using Raj. So here, so these last few. So this one was by doing the SUID through a script. So a script, basically, if you have SUID on it, you can run it as the root, since the root is the owner of the script. You can then change it to have the bash shell run, and then when you run it, it will have the bash shell run. These two, they're this one is kind of like the first one we saw above with the copy command. You edit the /password file, and then you put your own user in it with the root privileges, and then put it back. So you've created your own user with root privileges. Now then over here, we have this method. So this method just directly goes to the /etc/shadow file. This contains a lot of information. So there's also the encrypted passwords. Now, encrypted passwords, we have John the Ripper tool here. John the Ripper tool to decode it. So it gives the password, which in this case is 123, and then you can log in through the user. So then, that is all of the methods listed in this article. So to summarize this article, we have the first method over here. This is the one with the copy command where it has SUID. So this one, we have edited the password file using, we've edited the password file by opening it, and we can put it into /temp, because /temp can create or delete any file, as said here. So we can put your password file in it. Then copy can be run as the root. You can then override it with a copy you put in /temp. So the old copy did not have your user with the root privileges. The new copy does. So you have created your own user by editing the /etc/password file. So you have gained permission. So the second method, this is also with the copy command. This one involves taking a backdoor. So over here, you create a new file with the backdoor. Since copy has the SUID, you can copy it to /etc/cron.hourly or any of the cron tabs. So after you copy to the cron tabs, after you copy to the cron tabs, then it will run. Then it will then run after the designated time. So in this way, you can run your own backdoor, and then you can, so you gain your own backdoor. So in privilege escalation using find command. So similarly, we can escalate root privilege if SUID bit is on for bit find. So this one allows you to use the find command as any command, which can be pretty useful. Vim editor. So privilege escalation using Vim editor. This one allows you to change the sudoers file, and then you can give yourself the same permissions as the root. So if you can see here, the Ignite has the same permissions as the root now. So the next one is using saved script. This one is about SUID for any script or executable. So then if you have the script for the SUID, you can then put a bash shell into this script. And after you put a bash shell into that script, you can then run it. And as SUID, it will run as the root. So you've opened the SUID as the bash shell as a root. So you have a shell as a root. This one with nano editor. So nano, you just want to open up the /password file /etc/password file. And then after you open the /etc/password file, you can then edit it. And then after you edit it, you can just save your changes. And since you've edited it with this new user who is a root user, you now have a root user to go into the system with. So for this second nano method, we can just so for the second one, you just get the /etc/shadow file, and then you copy one of these guys' encrypted password, use the John the Ripper tool right here to decode it, and it will give you the password. So these are a few ways to just use the SUID for certain commands that have been turned on to use it in order to escalate your permissions. So this has already been put in the chat before, but I'll put this article link in the chat again so you can read it. And then I'll give you some time to read it. You can just say when you're done reading it and understand it. And then you can also practice it if you want to.
So Ethan, I think it's better ask people here just do a quick exercise. So better, because the article is kind of long. We can do a quick exercise. Okay. Let me share my screen and we can do a quick exercise together because otherwise you probably cannot remember. Okay. All right. Okay. You guys can see my screen? Okay. So I know here Ethan talked about several different ways to abuse this UID for permission escalation. And so basically the idea is, remember on Linux, it's all based on fair permissions, right? A lot of time if you want to do something, you don't have permission. But if you are root, you can do anything, right? although now we in our practice image we can run sudo, but if for a bad guy, if he comes to a machine, most of the time the first step is to get a regular user account. He has a regular user account, he want to escalate, but a lot of time he doesn't have the sudo. He can, so one way is to look upon the program that has that set UID permission set. Right? So this is the command, right? This is command basically as is explained to find all the programs with set UID permission set. Okay, let's take a look about one. Like, okay, let's look at the Bing. If we look at if you look at the details of this file with set UID bit, you can see this one is not RWX, instead it's RWS. So this one, the third bit on owner now is set to S. That means this guy has set UID enabled. So this one is not X, but a S. So this one has a set UID enabled. And because this file is owned by root, that means when this program runs, it runs as root. So we want to build this kind of files. Say if there are any programs, maybe by careless programs, system admins put there with set UID enabled. For example, we know the password file PSSWD under etc. Okay, not password, shadow file. Sorry. Yeah, the shadow file has encrypted password for the users, right? But by default, this one you really regular user will not be able to see it because this one is owned by root. Yeah, you can see it's owned by root. So so you really cannot see it. If right now that's because the cat command doesn't have the set UID. If we can somehow change the cat command with set UID enabled, then you will be able to see the shader file because when you run cat, it runs as a root. And so the change, of course, this one is demo, so I have sudo because change mode I need to have run with sudo permission. User with set. Where's cat? I think it's a USRB. Oh no, it's Bing cat. Okay, let's take a look. Now you see I have the cat utility with set UID set. Now when we run cat, it has the root permission. So right now if I run this cat etc shadow, I'm able to run it. Right, I don't have to use sudo. That's because the cat program itself provides me the root permission. And you can see this is the user I have. This is the user, right? Test1 user, and this is the encrypted password. So if I have access to this file, I can copy the password out and I can run offline. Try to crack the password. Also, this is the user of me. I can run offline cracking to crack the password, right? Yeah. So. And I can change, I can remove this permission. Now if I run it, my permission is denied. Yeah, so this is a kind of quick demo to show how to find the files with the set UID permission. And if you want to do a quick exercise, you can pick a file, pick a program, and change it and run it. See if you have the root permission. Especially for those programs, sometimes you have, I have to run sudo to change it. And now, if you change with set UID, you don't need sudo because everyone can run it. And it runs automatically as root. Yeah, I think. Yeah, maybe give you guys 3 minutes and try. Try a quick exercise.
Okay, so it's been around 3 minutes. So I think you should be done now. So let's talk about more of the privilege escalation. So we talked before about this SUID. So just to recap, even though we've already done a lot of recaps, you can make a new user by changing the /etc/password file. You can also change these get the password from the /etc/shadow file, create a backdoor and put it into Cron Jobs, or change some files to have the user have root permissions. So all of these involve some commands that you are going to able to be run as root, because SUID allows you to run the command as the SUID allows the command to be run as the owner, and in this case, after you've searched it up, the owner is root for all these commands that you've searched up. So just use the commands to be able to run them as a root and do things that you wouldn't normally do, but since you are there's the SUID enabled, so you are going to be able to run as a root. So that is mainly about the SUID. You can run that as a root. So then we will have to talk about some more privilege escalation. So these might not be directly related to the permissions, but they're still probably going to be pretty related. So let me pull it up. So okay, wait a minute. Okay. So let's take a look at this. Let's see what it has to say. So the root Linux provides full automated labels to the operating system. You may gain low privilege shell on a Linux host and need to perform privilege escalation to the root account. So fully compromising it may gain to capture traffic and sensitive files, which can advance us into the root. So enumeration, it says enumeration is the key to privilege escalation. Several help scripts such as Enum can assist with it. It is also important to understand what piece of information to look for. So you need to know the distribution, what kind of distribution it is. It will give you types of tools along with the OS version. You might need to know the specific kernel versions, vulnerabilities, and the running services. So, and all these running services, installed packages, logged in users. So home directories, home directory contents. If you find an SSH key for your current user, this could be used to open an SSH session on the host. Again, a stable and fully interactive session. It could be levered across sections of the network as well. At minimum, catch the cache, see what other tools hosts are being accessed. The SSH directory contents. It is also important to check a user's bash history, as they may be passing passwords as an argument on the command line, working with Git repository, setting up cron jobs, and more. So sudo, list user privileges. So these configuration files. So gain permission to view these configuration files. If you look throughout them, you can find some very, very interesting stuff. Readable shadow file. If you're able to read it, you might be able to gather password hashes for all users who have password set. While this does not guarantee further access, it can be subject to offline brute force attacks to recover the clear text password. It was set over here. So John the Ripper. So yeah, as I said before, you could use a tool, external tool like John the Ripper, to find the shadow password. So you might want to make sure that the shadow password permissions are very thorough and safe. Along with these configuration files, they can contain a lot of stuff. And as said before, if you the copy command up here, it doesn't apply only to /etc/password. You can also use it for the other stuff. So you can also edit another one of the configuration files in order to further your attack. So you will occasionally also see password hashes in the /etc/password file. This is readable by all users, and once again, they can be subject to the attack. So you also might. Oh yeah, so this link I will also send it into the chat. So you also don't want to be putting your password hashes in /etc/password. You should probably let everybody be able to read it, but don't put your password hashes there. So over here is a sample of one of these password hashes. Yeah, so one of these password hashes is like right here. I don't have John the Ripper or any of those tools in my computer, so I can't directly decode it. But I'll send it into the chat. If any of you have one of these tools, you might want to do. Yeah, you can decode it if you want to, I guess. So cron jobs, as said before, cron jobs, they're executing tasks as automatically every so often. This is one of the reasons why in Cyber Patriot you might want to be checking the cron jobs, because there could be a task in there you don't want to run. For example, in the copy command over here, we have seen that somebody could put malicious cron job into your cron jobs, the backdoor opening, and then they have a backdoor to infiltrate your computer with and stuff. So if you discover and came out an additional drive or file system, you might be able to find some files or passwords that can be used to escalate privileges. So file system and additional drives. So these set UID and set GID permissions. Binaries set with these permissions allow the user. Yeah, so this is what we talked about earlier with these commands over here, like copy and nano and find and stuff. So these are what we were talking about over there. And it said right here, they can be exploited to get a root shell. So as I said before, definitely want to be careful with what you're allowed to do with this. And writable directories. If you want to download tools to the system, you could see where a writable directory is, and then you can see where cron jobs are and just we use elevate purges in the script. And the cron job runs is also writable. So finding writable directories. Writable files. Are any scripts or configuration files word writable? While altering configuration files can be extremely descriptive. Maybe instances where a minor modification can open up further access. Also, any scripts that are run as root using cron jobs can be used to modify to slightly append a command. As said before about these permissions, you probably don't want to let just anybody be able to write your configuration files. For example, in the first example, we saw that they pasted in a new user into /etc/password. And then they gained root access. So as there was also up there where it said that the root, it was somewhere up here where it said that they might find something in /etc/password. So yeah, so if you put that there, you might get drooled. But overall, the writable files, you probably don't want to be letting your writable configuration files be writable. So like the /etc/shadow /etc/shadow. Yeah. So if you look at it here, there's this encrypted password over here. So if that file is writable, then somebody might be able to change that password and just make life harder for everybody. So there are various ways to just attack and escalate your privileges as seen from here. You first probably want to know what you're dealing with, like what type of stuff you're dealing with, like basic information, and then go check and nitpick to see if you can find any information like their home directories. Some cybersecurity competitions, they have, yeah, it's over here, not uncommon to change files credentials. They have a password file. For example, it could be called maybe password.pdf or something, and it could say, oh, root password is root. Bob's password is Bob, and Balin's password is Balin. So if you find something like that, that's going to be a lot, which is why they give you points if you delete those files. Also, home directory files, you could see files such as history, bash history file. They're readable. Sometimes they may have inputted their password as an argument. So also the SSH key, you can use this to open SSH session. Bash history. So once again, the sudo privileges, can you run it as another user or not if you don't have the credentials and stuff? Sudo, these are basically just looking for, once again, these configuration files. You look for these, you can find a ton of stuff. The shadow file, if it's readable and you read it, said before, you can do something like John the Ripper. Here's the hashed password, and then once it's decrypted, you have 1, 2, 3. If the shadow file is readable, you could do something like that. So just make sure your shadow file is probably not going to be readable to everybody. And also the password hashes in /ed/password. Occasionally somebody might have their password there. It's readable by all users, so you might not want to put passwords in there. Instead, put it in the shadow file. The cron jobs. So the cron jobs, as was said before, we have the cron jobs here. They run at a periodic interval. So if you can put something in there, that's going to be beneficial to you. Like up here, we had the copy with the backdoor. So if you copied a backdoor script to there, then you would have a backdoor running periodically, and then you would be able to access the system. Now here we have file systems and digital drives. Here we have the SUID. This is what we went over before, where you are allowed to run a file as the root. As the owner of the file. If it's root, then you'll be able to run it as root. If it's not a root, then you'll just be able to run it as the owner of the file. And also these writable directories. Writable files. Are there any scripts or configurations files for writable? So these are like, so the configuration files, these are files that configure it. You probably know that. And then if you edit these, you can change the system a lot. It says can be extremely destructive. But while it can be extremely destructive, it can also give a huge advantage to you, because if you looked up here, once again, the password file, you have put in your own root user as box in yellow here. So that's editing a configuration file. So then you have gained a lot of stuff. Writable files. So then that is it. So that is probably the recap for this. Know what you're dealing with. Look for any configuration files, home directories, files that might have information in them, executable files you can actually execute, and the SUIDs. Let me find them. SUIDs. These are what we discussed before. Said that like 3 times. And the cron jobs. So overall, there are lots of things to look out for. So lots of things to look out for there. So let's look at maybe we can look at another thing. So this might not be as related, but let's see how this works. So here we have this. So least privilege, principle of least privilege, means that they should only be granted privileges that they require to complete their tasks. This is also very applicable in real life. For example, you only want to give janitor keys to the cleaning room, the tools they need to clean, and the keys to the places they need to clean. You don't want to give them your financial records, tax fraud accounts, or the time you went to a vacation in Cuba. Basically, only give like an employee or somebody the stuff they need in order to do what they need to do. So, for example, as I said before, like when application only needs read access, should not be granted write or execute permissions. If an attacker hijacks an application and runs that with high privilege, the attacker can gain permissions. In reality, many applications and services run using high or even root permissions. This can be seen using the SUID because the root owner, you can run it as that. This is because systems lack the granular permissions control needed to apply the principle of least privilege. So once again, you need to make sure your permissions are looking good. You don't want to give things wrong permissions or people wrong permissions. Sometimes people forget to apply best practice. Sometimes people do shortcuts. Don't do shortcuts, especially in something like this. If you make a shortcut, it could really bite you in the butt later. There are also many examples that shortcuts is generally not a good idea. Some applications that aren't meant to be using high privileges do not implement the appropriate safety precautions against attackers. Like maybe this copy command, as we've seen before, when run with the root privilege, can actually be pretty dangerous to your system. So let's look at some things attackers can do. So a command injection. So a web application suffers from classic command injection attack. So here they injected some commands. It allows users to read a system file by submitting file name via a GET request. So this is bad. It lacks validation of the system call and enables hackers to execute system commands via command injection. So what if it has root privileges? So this is kind of like the shell. Wait a minute. Yeah, it's a lot like the bash shell you open as the root. They can inject commands into here. So for example, the attacker can do a lot worse because the command injection for root privileges. For example, /etc/password is editable with root privileges. They can add themselves as a root by editing the /etc/password again, giving things you might not want to be giving root privileges. Once again, this editing the password file and the nano. The command below, 0 is the UID of the user. So adding somebody with UID of root 0 will give them root privileges. So over here, they have added the user Vicky and an empty password as a root. So here we have a database injection. So they can achieve RCE through database injection. Many applications and services allow attackers to run system commands through an injection. This is a lot like some of these CTFs where you use the SQL injection to just log in and not have to do anything. You get the flag and then you win. So let's look at these SQL injection, for example. If they can get access to this SQL database with root privileges, what can they do? So the copy to from program function allows database users to execute code in the context of the database operating system user. First, the attacker needs to create a table to hold the system command's output, and they can run like a system command via the copy to from. The damage an attacker causes is limited. database runs that as low privilege user. The attacker might be able to read some files and gain more information about the machine. But if the database is running as a root, things can be way worse. So, for example, if it's running as the root, then they can get a lot of information. So they can echo this into EDC password. So echo, they just put this into EDC password. It's a lot like this one up here where they put their user into, or rather root user into the EDC password. And here they also did it. Here they also put a root user into EDC password. Exploiting a path traversal vulnerability. So path traversal attacks on this endpoint of a web application. An attacker can read files outside of the current directory by using the sequence .. This just goes back one. So here they are reading .. blah 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 all the way etc shadow. So it is a file in Linux systems that contains the hash passwords of system users. You probably know this. If they have permissions to view the etc shadow file, once again, as the previous one said before, if you can read the etc shadow file, you can use the tools like John the Ripper in order to find the hash passwords of people and unhash them. So now you have their passwords. They can crack the passwords, and then gain access to a privileged user's account. So here we have exploiting Redis. So let's look at another example. If an attacker gains access to an overprivileged instance, they use Redis to escalate their privileges on the system. So let's see how this attack will work. Attackers could use Redis to write their RSA public key into root authorized keys file and gain root access through SSH. Let's say an attacker were to gain access through an Redis server. First, the attacker needs to locally generate an SSH public key and private key using the keygen command. And they pad and top bottom file with new lines, as seen here. They can connect to the Redis server to write the key file. Finally, the attacker configures Redis and writes the public key file into the authorized key file in /root/sh. This will put the attacker's public key in /root/.sh/authorized keys, granting the attacker root access over SSH. The attacker can then log into the server with the corresponding private key. So these four, the first one is using commands. Ejecting commands in order to install your own user into the /etc/password file or something, and then give them a root privilege. The next one is the database injection, where you inject stuff into the database. This will change it, and you can inject your own user with the root privileges into the database. Here we have the path traversal vulnerability, where it can go back and maybe view a sensitive file like /etc/shadow. You can then unhash the passwords. Here, you can use your, you can generate an SSH public and private key and put your key into the root section of it. And then once you log in through SSH using this key pair, you're logged in as root. So these are attacks introduced by overprivileged process. They can be carefully configured by never using run as root as the default solution. So like here, these are all using the SUID, using the root user. So these have the root privileges. So then you can use the systemctl unit files to run a service as a particular user or group. In Linux, the unit files contain configuration records that will control a service's behavior. So it's closed 3 sections: unit, service, and install. You can add a user or group directive in the server section of the service as a unit file. Doing so will direct the service to run its user or group. So over here, this is looking pretty similar to the SUID, as you can run it as the maybe root user. You can read more about it there. In cron tabs, you can specify the user. They'll execute the command after enter time fields. So you can, you can execute the command like this. You can choose you want to execute it. It's also a good idea to carry out everyday tasks as a lower privilege user rather than constantly logged in as root. This is also good advice because you don't want to be randomly doing something that is irreversible as a root. You can also use security commands such as chroot, seccomp, and all these to help. So problems caused by lowering privileges. So sometimes execution will break if an application is not run as root. This is because the application needs to access to a file that is not privileged to access, or an application should bind a port number is less than 1024. For numbers less than 1024 privilege ports that only root users are allowed to access. Once again, let's bring up the janitor access. If you don't let the janitor have access to any cleaning tools, then you're going to have a little bit of a problem having the janitor do his job. He cannot clean if he does not have the tools. So to resolve this, you can, when you lower application privilege, you can consider granting the application or user Linux capability rather than running application as root. Basically, giving them as much as they need, but not more than they need. So conclusion, applications and process should be only granted the privileges that they require to complete their tasks. Carefully configuring things is very important. Don't wrongly configure things. So in this section down here, this is about using lowering privileges and that kind of stuff. Just saying that you can change something, and also that very, very important. You don't want to be giving things permissions that they don't need. Like these. Wait a minute. So like these were all giving the SUID to all of these copy command, nano command, find command, all that stuff. Those things they don't really need that SUID. So you're giving them a lot of power. And when you give something a lot of power, they can use that power in a bad way. As you can see here, they have made their own root user that you don't want in the system. And they have successfully given a root user to your system. So there are 8 minutes left. I will post this into the chat as well. In case if you want it, I'll post it in the chat. So you can use these 8 minutes to try to practice some of these stuff that was explained in one of these two. So I'll stop sharing my screen. Remember that both of these are in the chat now. I also posted one of the hashed passwords from one of them into the chat in case if you wanted to crack it. So you can use these last 8 minutes to maybe ask any questions and do some exercises.